You jumped the gun there, son. False start. No, I'm leaving that. Everyone online is going to know that you have no patience. Here we go. I'm not even la la la. Can't hear you. Continuing from where we left off. Okay? In sports, any sport that involves striking something, tennis, baseball, soccer, golf, players are told to follow through when they come in contact with the ball. Why might this help the ball leave with a greater velocity? Who's my baseball players? Okay? The reverse of this is think about what you do when you bunt and you don't want the ball to leave with a great velocity. Why would we follow through? What's that doing? Well, let's see. We want to change the ball's momentum. What's another word for change in momentum? Okay, so let's write down let's suppose I've lifted weights, I've trained as much as I can, I can't apply any more force. I've maxed that out. What other variable on the right-hand side can I control? Anthony. How can I make the time longer? 2 words. Follow through. What I'm really doing is I'm keeping the bat, the hockey stick, the golf club, whatever, in contact with the projectile longer. That's going to not change the force, certainly going to change the impulse. Okay? As t increases, impulse increases. Now, impulse is also mass v final minus mass v initial. I know enough in sports to know that if the impulse is changing, it's not the mass of the ball that's changing. What must be changing? V final. Also, because I can't control v initial. V final, it's going to leave at a faster speed. And that's why when you bunt, what do? Try and reduce. You're also trying to change the direction of the force. It's more complicated than letting on. But certainly, you're trying to reduce the time of impact as much as possible. Okay? You are also trying to lower the force because you're not doing a full-out swing. That's why it's such a dramatic change when you bunt. A good bunter can put it, down about 6 inches in front of them and have it stop dead if they do it just right. Right? What has more momentum? A 1,000 kilogram car moving at 100 kilometers an hour or a 2,000 kilogram truck moving at 50 kilometers an hour? What? It is. Now, technically, I should convert the kilometers per hour to meters per second because what you did was kilometers per hour, which actually is another way to measure momentum. It's just not the standard way. But yeah, if you go mass times speed, mass times velocity, you're going to find for both of these, the same. Well, Mr. Dueck, yeah, Kai. How come then in car accidents I seem to notice the semi-truck driver or the bus driver usually walks away okay, but the little car driver usually doesn't walk away at all? If there's the same momentum, and I know their final momentum is 0, Mr. Dueck, how come smaller cars are so much worse off in car accidents? Because it's not the change in momentum that kills you. It's the force. We'll talk about how that all works. Oh, and force is what times what? I lied again. It's not the force that kills you. It's acceleration. And if you have a small mass, because the semi-truck and the little car experience the same force, because forces come in what? Okay, so why is the big truck driver so worse off? MA, bigger M, smaller acceleration. Small car, bigger acceleration. Really, if you're wondering in accidents what it is that does damage, it's the acceleration. It's the acceleration. Not the force, not the change in momentum, it's the acceleration. Granted, the acceleration has an impact on the force, and so a lot of people say, well, isn't it the force? No. Hey, number 9. Does a moving object have momentum? Yes or no? Convince me. What was our first equation? How do I calculate momentum? No, that's impulse. What was our very first equation? The motion product, we called it. How do I calculate momentum? So if you're not moving, what's V? If V equals 0, momentum is 0. Oh, I don't want to. Okay? So if you're moving, you must have momentum. Example 10. Does a moving object have impulse? No. No? Convince me.
Impulse is the rate at which momentum changes.
Can you give me an example of a moving object that would have no impulse? Can you give me a shorter way to write not accelerating? 2 words. One begins with a C, one begins with an S. That has momentum, but since V final and V initial are the same, or the other way I can think about it, if you're at a constant speed, not only are you not accelerating, what's your net force? 0. In other words, I can think about it, if I'm at a constant speed, that's 0. Impulse is 0. Or I can think about it, if I'm at a constant speed, V final and V initial are the same thing. You have the same number minus the same number. You get 0. 2 different ways to think about it. So can you have impulse and be moving? Yep. But can you have can you have no impulse and be moving? Yep, constant speed. But if you're moving, you have to have momentum. Hey, when you jump from your lab table or from any height to the ground, why do you bend your knees as you land? Ah. What does that lower? No, it doesn't change your momentum. We're stuck with the impulse, because I know if you jump off something, we want your final momentum to be, well, your initial momentum is 0. Your final, when you hit the ground, is whatever the velocity you dropped at. You're stuck with that. What does it change then? In fact, you may have noticed it hurts way more to, if you're walking and there's an unexpected half stare and you didn't see it and you don't get a chance to bend your knees and you just do that half stare down, you feel that jar all the way through your spine, as opposed to if you jump off of a fence and you're prepared and you bend your knees. And there's way more change in momentum involved jumping off of a fence. It's the time of impact that you couldn't control because you didn't see the stare coming. In fact, you can really hurt yourself if you just have one stare and you didn't see it coming. Hey, which of the following situations is more likely to knock out a boxer? If the boxer takes the punch moving back, or if the boxer takes the punch moving in? Why? Okay. And by lengthening the time of impact, I can lower the force by, sadly, shrinking the time of impact. That's why if you ever watched UFC, most of the real knockouts are when the guy was coming in on attack and the person caught him in the jaw. You'll see very few knockouts where the person was moving backwards and got caught. Almost always they'll be able to shrug that off. Right? Got a few more to look at here. Part 2. Part 2. I called this, hey, more momentum examples. I think I wrote this lesson because some of these questions show up in the homework and kids were a little confused. Again, key ideas. What have we been talking about? Momentum and impulse. Key ideas. Momentum is mass times velocity. And then impulse is change in momentum, and I can find that by going force change in time, or I can find that by going mv final minus mv initial. All right. Example 1. Force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. Ben, what does part A want me to find?
You want me to find the impulse?
Ooh, I love the fact that you brought in the synonym. I got two methods. Which equation would I write down next, Ben, my friend?
You would use force
Mm-hmm.
changing time.
And then, Ben, without a calculator, in my head, really, Mr. Dueck, I would go 8 times 10 equals...
80.
That's a long memory, Mr. Sorry, I couldn't resist. As soon as I saw that, I'm going to Ben for this one. 80 what? You could either say, because it's momentum, kilogram meters per second. Here, since I went force times time, my tendency would be to say, oh, that one is Newton seconds. But Kyle, I'll take both. If I've used force and time, my answer usually, because it's in my mind, I'll go Newton seconds. If I use mass velocity, because it's in my mind, Emma, my answer will usually be kilogram meters per second. Emma, my angel, what's B asking me to find? I don't think I need a calculator. Because what's impulse another word for? Change in momentum. What did I find in part A? Ah, so are you saying the answer to part A is the same as the answer to part B? You would be correct. C. Kyle, what does C want me to find? What have I found in part A and B? Maybe there's an equation that has impulse and change in velocity in it. Now, this isn't one that I wrote at the top. This is, remember I had those 3 or 4 and I said I prefer this one? I think we can also say this. Impulse is also, didn't we say it was mass times change in velocity? I think? Yeah? Okay. How would I get the m by itself? Sorry, how would I get the change in velocity by itself? So you're saying, and I think you're right, the impulse divided by the change in momentum divided by the mass will give me the change in velocity. So the change in velocity is going to be 80 divided by 4. Dare I say without a calculator? Thank you. Now, what does that mean? That means your initial velocity could have been 0. Your final was 20. Your initial velocity could have been 5. Your final was 25. Your initial velocity could have been negative 10. Your final positive 10. Your initial velocity could have been negative 5. Your final is positive 15. I don't know. All I know is the change in velocity amounted to 20 meters per second. By the way, as a part D, I could say find the acceleration. Now, there's 2 ways. One is obvious. I could go force divided by mass, because F equals ma. 8 divided by 4 is 2. But the other way is I could go change in velocity over time. We just found the change in velocity. The time is 10. And you'll notice I get the same answer both ways. These are really overlapping. This is why I said to you, Sir Isaac Newton, when he wrote his force equation, wrote it in terms of momentum, not in terms of ma. Because he was delighted at how much this overlapped. Let's keep going. A snow scooter, woohoo, has a mass of 350 kilograms. Check. A constant force acts on it for 60 seconds. The scooter's initial velocity is 2.5 meters per second. Its final velocity is 18 meters per second. All right. Gesundheit. Dane, my friend.
Yes.
What's A asking me to find?
Change momentum.
Folks, which equation do I want to use here? Why can't I go force times time? Because there's no force. Also, glance at part B. What are they asking me to find in part B? force. You know what? It'd be pretty stupid if they asked me to find the force and they gave me the force, and Dueck usually doesn't run that. He makes the odd mistake, but never that bad. So that would be, you know, trying to teach you good test writing skills. Yeah, I'm going to use MV final minus MV initial. 350 minus 350. Double check, is there a change in direction anywhere? Does it talk about east and west or left and right? No, so I don't need to let any of these be negative, but I always double check. What's the impulse? What's the change in momentum? This one you can use a calculator for. Or maybe I can do it without. Let me see. 18 take away 2 is 16 take away 0.5. 15.5. 15.5 times 350 is going to be 3,500 plus 175. So 1675 plus, whoo, boy. 1675 plus 18 point. So let me, 1670. Double check, is this right, Mr.? Oh, this is way off. Hang on, it's 3,000. Try this again. Just to show Ben. It's going to be 350 times 15.5. Check. Which is going to be 3,500 plus 5 times that is going to be 50 plus half of that is going to be, is the answer 5,200? What is the answer? I'm close. What? Okay, 5,000. I heard just the 4. 5,400 and could have got it if I had to. Okay. Anita, what's B want me to find? Oh, what did I just find in part A? I bet you we'll use part A to find part B. Part A, I found change in momentum. Is there an equation that has force and change in momentum in it? I hope. There is? Anita, my angel, how would I get the force by itself? It's going to be 5,425 divided by 60 seconds. And I get 90.4 newtons. Now, as an advanced question, I would have no problem not giving you the time, but giving you the distance. Because if you know D and you know VI and you know VF, you can find T. Heck, for that matter, you could find the acceleration and even go mass times acceleration to find the force. So there's all sorts of other options as well, but this is pretty clean. Gets us there nicely. A rocket, woohoo! Of mass 2.6 times 10 to the 4th kilograms, starting from rest. I'd probably tend to underline that. That's always important. Is acted upon a net force of that much for that much. What's the final velocity of the rocket? What's this question want me to find? Is there an equation that has final velocity, force, mass, and time in it? Well, there is if I take both of the impulse equations and let them equal each other. If I say, you know what? Impulse equals impulse. What was that? Oh, and by the way, I wouldn't have to have started from rest. I could certainly handle this if we hadn't. So what I really have is this. Sheesh. I want V final. How do I get V final by itself? By the mass. All right. I'm going to get force, change in time, equals that. V final is going to be the force, 2.3 time. Mass, 2.6 times 10 to the fourth. .3 times 10 to the fourth times 120 divided by 2.6 times 10 to the fourth. You get 106.1, 106. Put your pencils down for a second, look up. Don't turn the page just yet. Take a look at that. What's another way to write force? F equals what? I could write that as MAT. I'll drop the delta. What do you see here? In fact, isn't it actually VF equals VI plus AT, but what was VI? Hey, here's yet another way we've proved, I think the very first equation we did all year, pops out of momentum too, if I'm a little bit clever. Don't even know that, but under nerdily cool, sort of nerdily cool. We're kind of coming full circle, and I like this. We're doing some review from the beginning of the year. Hey, we're halfway through April. Time to start thinking about some of that stuff from the beginning of the year. Number 4, a car of mass 1,600 kilograms moves at 32 meters per second. What braking force is needed to bring the car to a halt in 1.6 seconds? What's this question want me to find? A force. And it's given me a mass, a V initial, and a time. Oh, it's also giving me a V final. What's V final? Oh, okay. What equation can I use to tackle this puppy? Force change in time equals mv final minus mv initial. Except this time, yoink. And this time I'm getting the F by itself. Looks like the force is going to be negative 1,600 divided by 32 meters per second. That's about 60 miles an hour. We're stopping in 1.6, so brake. That's close to a panic stop. It's approaching it. It's probably going to be a fairly big force. If you're going from freeway speed to 0 in 1.6 seconds, you're about to hit something. Your fingers are probably clenching around the steering wheel. You get 32,000? Yeah, now that you see it, you're realizing the 16 and the 1.6 cancel. It's really 32 times 10. Yeah, fair enough. 32 times 1,000. Negative. What's the negative saying? If the car is moving to east, what direction is the force? West. If the car is moving north, the force is south. If the car is moving right, The force is left. So I'll keep the negative in there, and it's a force. By the way, what if I have more time to stop? Do I need as big a force? As time goes up, what happens to this if this gets bigger? This is why when it's raining, slow down, give yourself more time. You need more time. You can't apply as big a force. All coming together. What do we have? Fire hose and, oh good, a couple more and I can shut up. Fire hose. Really? Yeah. Pours 24 kilograms of water each second on a burning building. The water leaves the nozzle at 60 meters per second. It's coming out. Assuming that the spray of water does not bounce back from the wall, what's the minimum magnitude of the force on the wall of the building? I'll ask, have any of you ever been hit by a fire hose? Okay. On full?
Yeah.
Not pleasant?
Not pleasant.
Okay, there's a reason they use it as riot control, and there's a reason that when they do use it as riot control, it's frowned upon. Okay? You've probably seen from the U.S. in the 1960s during the civil rights movement, people being fire hosed by police or other law enforcement officials as they were standing up for their rights. It's not pleasant. And this is the minimum. The reason I said minimum magnitude is if it was actually bouncing back, the wall would have to be applying a bigger force. We're only asking how big a force does the wall have to apply to stop it. We're not asking, oh, and to send it back, bounce back. That would require even more. Okay. They gave me a mass. They gave me a velocity. They want a force. Help me out. What? You're saying I can go like... Again? Really? Oh, are you saying, I guess V final, when it hits the wall brings it to a stop? It wants a force. Wait a minute, they didn't give me time.
Or did they?
No, it can't be. This is, by the way, this is also why at the beginning of the year I said it's worth memorizing units not just to know what's what, but to know what's not what. Right? Can't be the 60, that's meters per second. Can't be the 24, it's kilograms. What? Look at them. They wrote it out instead of putting it as a number. So if I hear you correctly, Tawny, it's going to be negative, it's going to be 24 times by 60 divided by 1. Ben, will I need to use my calculator to divide by 1? No, but I can go, I guess, 24 times 60 if I need to. Although I think 24 times 6 is 144. So my guess is this is going to be negative 1,440, but double check me. It is? So some of us don't need to use a calculator for the top row either. Just saying. Units. Newtons. Direction, whatever the negative is saying, in the opposite direction that the water came in from. What if you wanted it to bounce back? Oh, then my V final wouldn't have canceled. I'd have a number in for V final. I need to know what speed I wanted it to bounce back, and I'd have to call that new velocity negative because it's in the opposite direction that it came in at. So if it said if it bounced back at 5 meters per second, I'd have to clue in the word back means better put a negative in front of it. Number 6, a mass moving that fast hits a wall. Oops, now I see compass directions, so I'm going to add my little compass rows because I saw the word east. The wall exerts a force to the west for that long. Find V final. Okay. Read very carefully. Read. Do you see 2 different directions in this question?
East and north.
East and north? Try again. East and west? East and west. By the way, that's why you'll notice I kind of don't like that north and Newton's. That's why I always put the at symbol in front of a direction if I can, right? Or I write out the whole word. You'll almost never see, well, anyways. So one of these is going to be positive, one of these is going to be negative. Read pick, and we're going to write that at the start just so we don't forget. What do you want to be positive, east or west? Okay, so I'm going to make a little note. All of us will. My abbreviation for positive is a plus with a VE. If I just put a plus sign, as a math guy, I'm always looking for an equation somewhere. Wait a minute, where's the number in front of the number after? So plus VE, I know that's the noun. You can use your own abbreviation, but there we go. All right. I'm seeing a mass. I'm seeing V's. I'm seeing forces. I'm seeing times. I think, yet again, vector, vector, vector. Should have done a vector up here. Should have done a vector there, too. Should have done a vector there, too. Should have done a vector there, too. And again, I'm not going to take marks off. I'm just trying to remind myself, Tawny, vector, vector. Especially with this east-west, it's easy to miss that, and your answer is going to be way off because you should have let one of the speeds be positive or negative or something. What's this question asking me to find? Oh, how would I get that by itself? Plus MV initial, because there's a minus in front of it, and then, okay, it's not on my formula sheet. I just derived a new equation. It looks like V final is rewrite the force delta T plus the MV initial over, divide by the mass. Okay, let's see. What's the force? 350 is wrong. Do you see how easy it is to miss that if you're in a, because you're so thrilled, I got the equation, and your guard goes down, right? Negative, because it does say to the west. Time. Plus, mass is a scalar. Positive, because it does say to the east. Now, before I crunch the numbers, if I get a negative velocity, how will I call that as a direction? West. If I get a positive velocity, how will I call that as a direction? Because that's why I wrote that. I wanted Reed to be consistent in our convention the entire way through. By the way, you could have let to the west be positive. No wrong in that. Just be consistent all the way through, and you'll get the same answer as me, because at the end, you'll convert it to a direction. Let's see here. V final is going to be, I'm going to need brackets around the top, aren't I? Negative 3, geez, try that again. Negative 350 times 0.075. Don't close off brackets. Plus 4.2 times 4.65. Okay, the entire top is in brackets divided by 4.2. Double check, double check, double check. Do you get negative 1.6? Which is 1.6 meters per second. They said find the speed. There it is. And direction to make it a velocity at, or you could leave the at off, but I'll put it there since we already earlier had somebody say and newtons was north. 1.6 meters per second due west. Last one. Oh, let's shoot some stuff. A rifle accelerates 12-gram bullets from rest to 250 meters per second. Okay? I'm already seeing a V initial and a V final. The rifle barrel is 0.85 meters long. Okay. Find A, the impulse, B, force. What's another word for impulse? Okay, so this thing, find the change momentum. Am I going to use force times change in time, or am I going to use mv final minus mv initial? Shaq, what are they asking me to find in part B? Okay, if they're asking me to find the force in part B, probably they didn't give me the force for part A. So I don't think I can use force times change in time. Sorry, what did I heard somebody say it here? Yo. So you're saying for part A, let's do a quick check. Do I know the mass? Check, although I'll have to change it to kilograms. Do I know V final? Yep. Do I know the mass? Already said I did. Do I know V initial? Yep. Oh, okay, this is plug and chug-ish. 12 grams. How many kilograms? Careful. 0.012 times 250. Oh. Why can I do that? Yeah, okay. So the impulse this bullet feels, 3. Wait a minute, Mr. Dueck. What? In that example that you did with the baseball last lesson, a baseball had 9 kilogram meters per second, and you said we were okay with that. This is a bullet with 3. It's got less impulse, less momentum. It kills us. Which has a shorter time of impact? A bullet hitting you or a baseball being hit? Which will exhibit a bigger force then, because time got smaller, force got bigger? Also, my speed is a bit slow. I think bullets probably travel closer to 400 meters per second, maybe more. B. Emma, what did I find in part A? Is there an equation, folks, that has force and impulse in it? I guess the force is going to be the impulse divided by the time, which is going to be 3 divided by the... Oh. Ugh. And Kai, I'm even reading for English words and I don't see time. Any suggestions? Oh, I haven't used distance yet? You know what? Even though this question said find the impulse, find the force, I bet you I'm going to spend most of my time finding time, no pun intended. So over here, let's do a little dfic. D equals negative 0.85 or 0.85, because it's a displacement technically. Negative 0.85 or 0.85. Based on our convention, is the bullet moving forwards through the gun barrel or is it moving backwards through the gun barrel based on how we got this set up? So positive. Just think about those things though, right? V initial, 0. V final, 250. And I want... Boy, it's been a while since I've said this phrase. Hey, do I have an equation that has D, V initial, V final, and T in it? The answer is I do the one of those that I used the least. This one. Or times a half. I can't remember how I wrote it on your formula sheet, but times a half? I like this version better. Oh. Why? So really what I have, this is why I like this version better, is this. D equals VFT times that over 2. Okay. Can I get the T by itself now? Yep. How? Oh, how would I get the T by itself? Times by 2? Woohoo! It's going to be 2 times 0.85 divided by 250. Should be a small answer because I don't think a bullet takes a long time to go through the barrel of a gun. No, that's wrong. Divided by 250, Mr. Dueck. That looks better. Yeah, and that seems about gut instinct right. Bullet probably takes a few hundredths of a second or thousandths of a second. 0.0068 seconds. And now, 0.0068. Okay, do that one in your head. 68's not a good one to do math with. Because 68 has a 34, has a 17 in it. Dividing by 17 is going to be a repeating decimal 16 digits long. Not going to do it. This is going to be yucky. How about 441? Did they ask for a direction? Not really, so okay. Forwards, I think, because the bullet's being pushed forwards. Don't make me come over there. I was reading and watching a video podcast yesterday from SciShow. It was asking, why do we yawn? And the current research says if you're feeling yawny, sleepy, try taking a deep breath and holding it. Pushing out without letting any of it out so that your muscles are tense, and apparently that will inflate your rib cage and pull more oxygen from that series of breaths than normal and oxygenate your brain in a few seconds, and you'll feel awake again. So if you're feeling yawny, if you're trying to stay awake in a class, I haven't tried this myself yet, but try and pushing out a little bit without letting it go, and apparently if you do that a few times in a row, you'll oxygenate your brain again. I don't know. At least it sounds theoretically feasible. I may try that during the next staff meet. Oh, jeez, I don't want that on the internet. Pause, pause, pause. Son of a... Jeez. Here we go. I heard that. So the sheet that I gave you, I called it Momentum and Impulse. There's 2 parts. The first part is 8 questions. Scrambled answers right there. So I don't have an answer key, but you should find all the answers there. Second one, this has some nasties. We can already answer number 1, though. How do seatbelts and airbags protect car drivers in a collision? Yep. You also see it, by the way, when you're heading towards the pit bridge, right before the cement barrier on the road. What do you see in front of it? You guys see them in front of most cement barriers now. Those orange things full of what? What does that do? Increases the time of impact. Instead of stopping with cement, it will slow you down gradually. Again, if we can double the time of impact, which doesn't take much, that's half the force. Hey, if we can reduce the time of, if we can quintuple the time of impact, which really doesn't take that much either, it's 1/5 the force. You can try 2, 3, 4, 5, 6, 7, and 8. The answers to those, I believe, are all in brackets, and I got a couple of videos to show you.